Well, hello students. In this video, I will show you how to go through all the steps that you need to test your code on the Karel GPS project. And we're going to go through these in a little bit of different parts at a time. But at this point, the assumption is that you've written most, if not all, of your code, and we just need to test this in different phases. And really, you should be doing this as you develop the project. So let's start out here. I have my main function. I'm going to take in a file, a world file called maze.kwld. And just to show you, this is what that world looks like. Okay, so we have our destination up here at Street 10, Avenue 9. Okay, and then the first thing that we're going to do is we're just going to make a map object, load it up with this file name, and then simply print out that map. Okay, and I'm going to show you what that looks like. So here, let's just compile everything. Right, and JCK is my shortcut for compiling everything with the Karel JRobot jar file, and then we're going to run it. And I'm going to save my the result of this to a text file just so that it could be easily read and processed. So I'll show you if I were to run it, I get all of this stuff. Whoa, that's not what I should get. Let's try that again. If I were to run it, I would get all of this stuff right here, and I have to kind of scroll through it, so it's kind of a mess. So in Unix, I'm going to run this again, and again, you don't have to do this if you don't want to. I'm going to have this this symbol here that says empty out all the results to the output.txt file, and then in here, you can see that this is my output file. So let's do a quick comparison of what we got in our output file versus what is going on in our world. So let's scan through this a little bit. So let's pick a random corner. Let's say we pick this corner, 8.2. This corner right here, right? That's 8.2. All right, so in here I am at that corner. I can search through my output file fairly quickly. The north is closed, the south is open, that's good. The east is closed, that's good because there's a wall there, and the west is open. Okay, and it's not that you have to check through every single thing. We'll know if it fails when we go to run this with the robot. But you should check some of the more interesting corners. So this is the area here that's all blocked off. Let's maybe check something that's somewhat open. So let's check 6.3. Right. So 6.3 is one of the corners where everything should be open. So let's see. Oh, there it is, 6.3. So this information about 6.3, north is open, south, east, west, that's all open. Okay, and then you should go through and check a few more. So let's say we go to this corner here, 7.6. Right. So let's see. 7.6 is a good test case because everything is closed except the east. So the north is closed, south is closed, east is open, west is closed. Okay, so on and so forth. Okay, so now that we can do that and we see that the world is working, we can add some more code to this. So now you see I've added some more code. I've created a GPS variable, naming it after the Grid Explorer Magellan, and I've passed in my map object into that constructor. I'm going to comment out this line of code right here because, well, we already looked at that. We don't want to get too much output here. And then I'm creating a array list of corners with the variable name that is path, and I'm calling Magellan find path. This is the starting street, the starting avenue, the ending street, the ending avenue. So basically what I'm telling my GPS class here is I'll start at 1.1 and I want to find my way up to 10.9. Okay, and I need to be able to the code needs to be able to tell me to give me that exact path, and then I'm going to print out that precise path here. Okay, so let's run this code as well. Going to compile. And then I'm going to run. And again, I'm going to run this once just to show you that I'm going to get a lot of information here, so that can be overwhelming. So what I'm going to do is I'm going to run it one more time, except I'm just going to save all of my output to a text file. And then I can go back into my code here. Okay, now we can scan through all of this. And notice here that this is not going to print out everything. This is just going to print out the path. So the first location that I get is 10.9. This is great because that's my destination. The second location I get on here is 9.9. So that's saying from 10.9, the one that came before that was 9.9. Okay? And then the one that came before that was 8.9 and then 8.8. So let's see. 9.9, 8.9, 8.8. So I'm going over here. And then I should see 7.8 and then 7.7. So if I keep on scrolling down, you see I get location 7.8 and then I get 7.7. And one more thing that I want to point out here in my in the stuff that in my output here is you notice that I have a location and then I have a variable called source. Now you may name it something differently. You may name it previous or parent or tracer, but this is exactly what this is how it should behave, right? If I'm at location 10.9, then my source or my tracer is 9.9. Now I go to location 9.9 and my source or my tracer is 8.9. And you can see that this gets printed out in a very logical order. And eventually, if I scroll all the way down to the bottom, I get my my second to last location is 1, 2, so that's right here. And then that source or that tracer is 1, 1. And then the last location that's printed here is 1, 1. And the source here is null. Okay, so if you do this correctly, if your GPS does its job, when you print out this information, the only time that you should see a source or a tracer of null is when you're at the very beginning. So it looks, at least from just doing some spot checking here, that my GPS algorithm is working. So now I'm going to take it to the next and final level here, which is actually have a robot run and solve everything. All right, so updated my code. Starting here, right, I've added all the stuff that's required to open up a world, read world, set visible, set trace, set delay, all this good stuff that involves the world of Karel. I've created a smart bot object called, the variable is named Borman, after the great astronaut Frank Borman. And I've put it in 1.1 directions.east, and then we're going to call Borman.walk path, the path. So again, my GPS, let's go back up just a little bit. I make a map called MP. I pass that map into my GPS constructor. Then I call find path and I save that result right here. So the variable path here is an array list of corners. And now I've made my smart bot that's actually going to do the walking. And I pass in that path, and again, this is an array list of corners, into my SmartBot object. And if all works out well, I should see the SmartBot walking precisely that path. So let's compile. Okay, this is a little bit slower than what I would like. And then run. Oh, I think I made a mistake. I didn't save my code. Whew. Okay, so hopefully, if that happens to you, you won't panic. Let's try this again. Code is saved. It compiles. It runs. And here is my world. You see my robot taking action. It's moving through. It's moving through. It's moving through that path. Boom. It's done. Okay. So you see how that works. And I know that you may be struggling, and there's lots of debugging that's going to have to happen. But it will be very, very satisfying once you're able to get the thing to work, and you can try all kinds of complicated results or mazes with it. As always, keep working hard. Thank you for watching, and have